Okay, in this lesson we're going to be looking at nth roots, and we're looking at how roots and exponents work together. Speaking of which, from this first screen here, the most important thing to recognize is this 1/2 over 1 over n exponent theorem. Basically what that's describing is when we have an exponent that is a fraction, the denominator is referring to the nth root of your base. So if we have x to the 1 over n, it would be the nth root of whatever x is. So for example, let's keep this simple. Let's say if I have 81 to the 1/2 power. This does not mean we take half of 81. This means that we're looking at the nth root, in this case the second root of 81, or the square root of 81, which would be 9. Let's look at some other examples. Again, we're going to do all of these without a calculator. Let's start with this first one. We're taking 125 to the 1/3 power, meaning we're going to look for the third root of 125. So again, we're not taking 125 divided by 3. That's not going to be our answer. We just simply take and figure out what times itself 3 times give you 125. Well, 5 would be your answer because 5 times 5 is 25, and 5 cubed then would be 125. So our answer would be 5. Let's look at the next one. You might say, well, I don't know what the square root of 1 over 36 would be. Well, basically what we do is we break this up into the numerator and the denominator. We take 1 to the 1/2 power and 36 to the 1/2 power, or the square root of 1 over the square root of 36. The square root of 1 is just 1, and the square root of 36 is 6. Your answer here would be 1 over 6. Now C you have to be careful with, because there's 2 possible types of problems that we could have here. I could have negative 16 to the 1/4 power, or I could have it written like this, negative 16 to the 1/4 power. In other words, the fourth root of 16 and the opposite of that. That is what we're doing here. We're only taking, the way this is written, we're only taking the fourth root of 16 because the negative is not inside of parentheses. So for this one, the fourth root of 16 is 2, so my answer would be negative 2. Now, if it had been written like this, my answer would not be negative 2 because negative 2 multiplied by itself 4 times does not give me negative 16, it gives me a positive 16. So there is no real solution that I would get here. In fact, the only way to get this would be to use an imaginary number, so our answer would be 2i. So that is the difference between these two, the way they're written. So this one here, my answer that they're looking for is negative 2. If it had been negative 16 in parentheses with the fourth root outside of it, or being raised to the 1/4 power outside of it, then your answer would be 2i. Let's look at letter D. That one's also a little tricky. That one is not, so it's 0.09 to the 1/2 power. That does not mean we just take, well, the square root of 9 is 3, so my answer must be 0.03. That would actually be wrong. Here's the way we need to look at it. This 9 is in the hundredths place, so I'm going to write this as 9 over 100. If I had 0.092, I would have that 0.092 is in the thousandths place, so I'd have 92 over 1,000, and so on. But this would be 9 over 100. And then the 9 over 100, we're going to raise that to the 1/2 power, meaning we're going to take the square root of 9 over 100. Very similar to what we did in B. Part B, the square root of 9 is 3, and the square root of 100 is 10. So my answer would be 3/10, or if you wanted to put it as a decimal, it would be 0.3, not 0.03, 0.3. So either of those would be your correct answer for letter D. I want you guys to give letters E and F a try. Letter F is kind of tricky, but I want you to see if you can't figure it out. But why don't you see if you can't work on both of these? And so pause the video and hit play when you're ready to check to see if you have the correct answers. Okay, so let's see how you did here. So to start out with, letter E is very similar to both B and C because it's similar to C in the sense that these parentheses are just around the 16 and the 81, so the negative is not included. So we're going to take the fourth root of 16 and the fourth root of 81. When you do that, you get the fourth root of 16 is 2, the fourth root of 81 is 3. But now we have to take this negative and apply that here, so my answer would be a negative 2/3. Looking at letter F here, my answer here would end up being, 100. And the reason why is an easy way to figure this out is we're taking the third root of 1 million. So what I like to do is if I'm ever stumped, if I'm ever trying to figure it out and there's a lot of zeros here, So we're dealing with the base 10. Group those up. So we want 3 groups of the same amount. 3 equal groups, basically. So I could break this up into 3 equal groups of 2 zeros, so my answer is going to have 2 zeros. Similarly, if I had 100 to the 1/2 power, so the square root of 100, granted, you know that's 10, but if you think about it, you're trying to break that up into 2 equal groups, and so you'd have 2 equal groups of 1 0, so that means you'd have 1 0 as your answer. Or if I had a problem like this, or if I had, instead of 1 million, let's say if I had 1 billion, and I wanted to figure out what's the third root of that. Well, I'd break that up into 3 equal groups. So I have 3 equal groups of 3 zeros, so my answer would be 1,000. So the cube root of 1 billion would be 1,000. Now for this next section here, the most important piece to get is this equation, y equals a times b to the x power. That's basically what it's getting at here. When it's in that form, y equals a times b to the x power, we have your a represents your starting amount, or sometimes they refer to it as your initial amount. B is your growth factor. Now that value for b, if we're dealing with exponential growth, that means that the value for b has got to be bigger than 1. If we're dealing with exponential decay, like situations dealing with depreciation, that value of b has to be between 0 and 1. And then x represents your time, and your answer y is always going to be your ending amount. So let's look at this example where we're going to use that formula. It says a bowling game that cost 50 cents in the year 1960 might cost $3 in the year 2010. What is the annual growth rate? Well, let's figure out what we know here. We know my initial amount is 50 cents. We're going to write that as 0.5 or 0.50. Our growth rate, that's what we're trying to figure out. X represents our time. Well, they don't say it specifically, but they say that this 50 cents is from the year 1960, and the $3 is the year 2010, so that's 50 years later, so X is 50. And Y is going to be my ending amount, which would be the $3. So you can say 3 or 3.00. So let's plug that information in now to our formula. So it's going to be 3 equals our initial amount, 0.5, times the growth factor, which we're trying to find, to the x power, which is 50. So now what I would do is to solve for b, I could divide both sides by 0.5 on my calculators, or 1.5 is the same as 1/2, so you can multiply both sides by 2. Either way, you get 6 equals b to the 50th power. So again, my goal is to solve for b, so I'm trying to get the b by itself here. Now there's 2 different ways that I could figure out what b is. I could take and raise each side to the 1 over 50th power. Or, to get b by itself, I could take the 50th root of both sides. So either way, you'll get the same answer, and I'll show you on your calculator how to do this. So your first step, let's do the 6 to the 1 over 50th power. So we type in 6, use your caret button for your exponent, and just do 1 divided by 50, hit enter, you have your answer. Now if you want to use the 50th root, for that one you're going to use the same caret button, but you have to control the caret button, and then type in that we want to find the 50th root. Arrow over to the right and type in 60 underneath the radical sign. Sorry, not 60, put 6 underneath the radical sign, and you get 1.036 as well. So either way, you get the same answer. It does not matter to me which method you use, so just find the one that you're most comfortable with and use that one. But either way, you get 1.036. Now the problem is we're trying to find the growth rate. So my rate is always going to be written as a percent. So I'd have to multiply by 100 or move the decimal to the right 2 places. Now when you do that, you get 103.6 or 103.6%. But the problem is we're looking for the growth rate. The 100% represents the initial amount. The 3.6% represents what you've grown by. I'm going to say that again. If we change this to a percent and get 103.6%, the 100% represents what the initial amount was. The 3.6% represents what we've increased, what our growth rate is. And that would be your answer, just a 3.6%. So So I want you guys try this next one on your own. So why don't you pause the video and hit play when you're ready to check to see if you get the correct answer on example 2B here. Okay, you should have gotten 5.9% as your answer, because we know that the original amount for the box of corn flakes was 25 cents, or 0.25. We're trying to figure out what the annual growth rate is. We're trying to find B. From 1965 to the year 2008, that's a difference of 43 years, so your time is 43 years, and our ending amount in 2008, the 12-ounce box, cost $2.99. So you divide both sides by 0.25 to get 11.96. Take the 43rd root, or take each side to the 1 over 43 power, and you get 1.059, which as a growth rate percent would be 5.9%. Let's look at another type of problem here. Here they give you the volume of a cone with the radius r and a height equal to the radius, as given by that formula. So they say give a formula for the radius in terms of v. Now when it says this phrase, for the radius, this first volume is solved for v. So it's v equals. We want to give a formula for the radius, so we want it in the form r equals. That's our goal. So right now it's v equals 1/3 pi r cubed. Now to get rid of a fraction, I always just multiply by what's in the denominator. So don't divide by don't divide by 1/3, or you're going to have a fraction inside of a fraction, because you'd end up with v divided by 1/3, and that's not okay. If it had been 2/3, you multiplied by the reciprocal, you'd still have a fraction on the other side, and then if we have to do more, it gets ugly. So just multiply both sides by what's in the denominator. So we get 3v equals pi r cubed when you do that. Now, again, our goal is to get the r by itself. So I'm going to divide by pi on both sides. Well, that gives me r cubed equals 3v divided by pi. And again, to solve for r, there's two different ways you could have your answer. We could have r equals the cubed root of 3v divided by pi, or you could have r equals 3v divided by pi being raised to the 1/3 power. And then in part B, it says a cone with radius r and a height equal to its radius has a volume of 60 cubic millimeters. Use the formula in part A to find its height. You might say, well, wait a minute. If I put a number in here for the volume, I'm getting the radius, not the height. How do I figure out the height? The radius and height are equal to each other. So we could put h in here if you wanted to, or r, doesn't matter. But either way, you're going to take 3 times your volume, which in this case is 60. Divide that by pi. And then I'm going to use the first one. I'm going to take the cubed root. And when you do that on your calculator, you end up getting 3.86 millimeters as your answer. We're not going to do this next example. I want to end by talking about this piece here. So what you might want to do is pause the video and make sure you write down what I have here. I really don't like the way the book described it, so that's why I kind of reworded things here to make this a little bit easier. And I'll try to make sense out of it. This first graph, what this is showing us is this is graphing y equals x to an odd exponent. If I graphed y equals x to any odd exponent, I'd get this kind of zigzag line that's in quadrants 1 and 3. If I graphed a horizontal line, y equals k, it's always going to intersect that line, that blue line, in only one spot. So like if I had y equals a negative number, it would intersect down here in one spot. If I had y equals a positive number, it'd intersect here at one spot. If I had y equals 0, it'd intersect here at one spot. So it doesn't matter what k is, there's always going to be one intersection point. What is the significance of that? Well, here's what this is illustrating. If we have an odd power function, so if I have an exponent that's odd, so if an odd exponent that's equal to, so if I have that function equal to a positive or a negative number, it's always going to result in only one real solution. Now, why is that important? Because there are times where you could come up with more than one solution, exactly one solution, or no solutions if it's an even power exponent, or if an even power function. So if it's an even power function, what they're showing us over here is that even power functions are parabolic. So they look like a parabola. If it's y equals x squared, it would be a parabola. Now let's say if I had x squared equals 81. That means that if I had the graph y equals x squared, if I graph the line y equals 81, they would intersect at two places because I'd have two solutions. Those solutions would be, because my calculator, if I took the square root of both sides, my calculator would give me 9 as my answer. but that's only one of my solutions. The other solution would be negative 9. So you need to make sure that you know that when we're dealing with an even power function that equals a positive number like 81, there's always two real solutions, a positive and a negative. Now, if you have an even power function that's equal to exactly 0, there's only going to be one intersection point at the vertex. So if that's the case, if you have an even power function equaling 0, there's always one real solution. And if we have an even power function like y equals x squared equals a negative number like negative 81, there's going to be no real solutions. The reason why is there's no number I could square that would give me negative 81 as my answer. So let's just also summarize by looking at this box here. The key thing here is to understand the second point. When we're dealing with a situation like this, an nth root of x, and if you're dealing with x where x is a negative number, and the nth root is odd, there's always going to be one real solution. Okay, that's what they're basically saying here, is that odd roots of negative numbers always result in one solution. Well, the flip side of that then is that if you have even roots of negative numbers, they always result in no real solution, which we've already talked about a little bit. Like, for example, square root of negative 64 is not going to result in a real solution. So what I have to do there is, remember, if we're dealing with an even root of a negative number, we factor out an I. And so then we have the square root of 64. The square root of 64 is 8, so my answer is 8i. Now when I say even root and odd roots, it's referring to the root that's out here, not what's underneath. So you might say, well, wait a minute, this is negative 63, so that's an odd number. Well, it's still an even root of a negative number. So I still have to factor out an I. And this you have to use on your calculator. The square root of 63 ends up giving you 7.94 if we round to the nearest hundredths place. So it would be 7.94i would be our answer. So if it's an even root of a negative number, it's not going to be a real solution. We have to factor out an I. Well, that's it. That's all we're going to be talking about. So again, this lesson is all review of things that you've already done in advanced algebra, but it's really important that you make sure that you still do the assignment, even though you might think that, oh, I remember how to do all this stuff, because you need to make sure that you practice it to make sure that you can refresh your memory on how to actually do some of these problems. So with that, good luck now as you work on your assignment.